Okay, today's subject is multi-rotor helicopter drone train concept. I've talked about this one already. Lots of very interesting characteristics about this. I want to talk about the small scale prototypes. So this is a small scale version of the helicopter drone train wire tree. I kind of consider this like a kind of a wire tree concept because it looks like a tree. A wire tree motorcycle. In reality, this would look a lot different. I'd make this look a lot more interesting. But basically, it's a type of hollow vascular wire tree endo-exoskeleton roll cage type of. So, safety. Why? Why do you want this type of kind of ridiculous design? Safety. For personal safety, safe flying machine. Why do you want it like this? In reality, I've talked about this I've done a lot of research. I've been doing a lot of research about aviation, okay? Each engine rotor, drone rotor, would probably be around maybe a 50cc two-stroke drone motor. Each rotor is about maybe a weed whacker sized drone motor and rudder. Why? Because of safety. Because a weed whacker is pretty. You don't want to get hit with a weed whacker. If you stick your hand in a rotor blade, it has enough power to really hurt your hand. And it won't chop off your hand. You don't want to get your hand chopped off. Instead of one big rotor spinning around, technically a big blade spinning around, you stick your hand in it, and it's going to chop your hand off. Using smaller rotors, I think the typical weed whacker rotor engine is about 30cc. And at that power level of 30cc, if you stick your hand in the weed whacker blade, which it happens, it's not going to chop your hand off. You could get a weed whacker motor to run on 200 psi. 200 psi can get a weed whacker rotor to work. So if there was like some type of 200 psi fuel pump system pumping fuel to all the engines in the rotor, you could possibly get this thing to work, to run on high pressure, 200 psi air pressure and fuel pumps. And that would be almost the equivalent of like turbocharging the drone rotor. So the idea here is we're turbocharging the drone rotor using air pressure and fuel pressure to pump into the drones. I would rather use gas powered two-stroke engines than electric right now, because the batteries for electric vehicles are just too heavy for flying machines. You get very limited range, and it's not going to go very far with batteries. Until the day we get better batteries, you're just not going to get enough power to weight ratio with battery powered drones. I think it's going to have to be gas powered. And so you would have a fuel pumping system, fuel and air pumping system throughout the entire vehicle that would pump 200 psi of fuel and air pressure into all the engines, and it should be enough to power a rocket thrust vector effect. For example, a lot of World War II aircraft didn't have an exhaust. It would pretty much vent the exhaust straight out of the engine, out of a kind of thrust vector on the engine, and it would actually increase the efficiency of the vehicle by 10%. So by using the engine exhaust as a thrust vector effect, you are able to increase the efficiency of a vehicle, of an engine, by 10% by venting out the exhaust in a thrust vector. So another reason, so the idea here is safety for personal flying vehicles. That's the top priority when it comes to safely flying commercial, civilian, lightweight vehicles. So there's a certain weight limit. I have to keep this down. If I want to make this in real scale, I want to do this, but a small scale prototype of my drone train concept, wire tree. So it's hollow vascular because it's aerodynamically neutral. Using drones, why would you want a wire tree like this? Because it's aerodynamically neutral. You want the airflow to pass through and over the vehicle without obstructing or displacing the airflow, because I'm using thrust vector effect. This is not a typical wing. This is powered by thrust vectoring. So I don't want to obstruct the airflow. Okay? So this would be about the size of a car. This is a motorcycle, a very large motorcycle concept, but the size of a car. So there's a small scale prototype. And then there's like this. So it's like a wire tree because you want to protect the rotors. As a personal flying vehicle, you don't want to accidentally stick your hand in a rotor. So it has a cage around it. The wire tree endoexoskeleton is like a cage around, the fan cage around the vehicle. So you want to use a type of safety. Safety is top priority when it comes to personal flying vehicles like that. So why use a whole bunch of smaller drone rotors instead of one big helicopter rotor? Because of safety. This I'd recommend putting the big top one in a cage or something. So that's the reason for using a whole bunch of small drone rotors compared to one big drone rotor for safety. Because yeah, you don't want to put your hand in the rotor. These smaller engines and smaller rotors are going to be very painful if you stick your hand in it, but it won't chop your hand off. It won't chop your head off. It's very painful. You don't want to do that, but it's not going to chop your hand off, okay? So that is why I think that having multiple rotors on a wire tree endoexoskeleton is going to do the trick. You don't want to get your head chopped off when you want to go fly your vehicle. If you were to accidentally do so, it's going to whack you in the head really bad, but it's not going to chop your head off. So that is why I think the smaller engine, smaller rotor, propeller prop, multi-rotor propeller prop concept in this wire tree drone concept works, because I'm using fuel, air, two-stroke engines, very reliable, and it's not going to kill you. And it's redundant. There's backup on the backup. So if an engine goes out, you got a backup engine. Backup gyro. It's safety. Safety is top priority when operating a type of vehicle like this. So I'm thinking about personal safety, redundant, reliable, small scale vehicles that would be able to be practical and functional. This is small scale, about the size of a car, so we could park in your car, park in your garage or something, you know? Okay. Thank you. Bye-bye.